Let's start with the total basics. A bit is the smallest piece of information a computer can store and work with. A bit has two states, 1 or 0. It's like a light, on or off, or a door is open or closed, heads, tails, on, off. A byte is a group of bits. We have our torch, on, off. Now imagine we've got 8 of them. I mean, a byte can have different sizes, but in this video we only care about 8-bit bytes. When all our torches are off, we've got 8 zeros here. If we turn one on, then we have 1. If we turn another one on, then we have two ones. If we turn them all on, then we have 8 ones in a row. The way that binary works is each position is a power of 2. With the rightmost bit, we can represent 0 or 1. With the next one, we can represent 2 or 3. With this one, we can represent 4, 5, 6, 7. Next one, we can represent 8, 9, 10, 11, 12, 13, 14, and 15, and so on. If we add them all up, we can represent the numbers from 0 to 255. So all off is 0, all on is 255. So in hexadecimal, from 0 to FF. So decimals, integers, is how humans understand numbers. Hexadecimal is how software represents them compactly, and binary is how hardware actually stores them on the disk. You know, electrical charge levels in tiny flash memory cells having a trapped electron or not. So you might be asking, what's the point of numbers between 0 and 255? That seems a bit limited, but it's really not. That's how everything in computing is stored. So my first computer was an 8-bit computer, so that's all it could represent. Everything was in 8 bits. The ASCII 2 character set could only have 255 letters. 65 represented A. Color channels and images would be 0 to 255. How much red, or how much blue, or how much green. But then when you put them together in a sequence, it then becomes really powerful. This can represent 255, but put 2 8-bit bytes together, and then you can then represent 2 to the power of 16. Which is, you've got the numbers 0 to 65,535. If you put 4 8-bit bytes together, you've got 32 bits, and you can represent 0 to 4,294,367,295. Or if you put 8 8-bit bytes together, you've got 8 times 8, which is 64. So you can represent 2 to the power of 64 numbers, which is 18 quintillion or something. So this is how larger integers are represented. We just line up the bytes end to end. And then that's how we represent everything with computers. So an image is just a load of bytes in a sequence. A video like this, a game, a program, everything is just encoded as a sequence of bytes. We have this image here of the byte cake. And if we just open up with a hex editor, the file starts with 89, which is ASCII is a dot, 50 is a P, 4N is an N, and then 47 is a G. That's the magic number at the start, which is telling the software that this is a ping image. There's actually some metadata, and there we go. And then eventually the whole image is encoded as a series of numbers. So in Python, a bytes object is a sequence type where each element is exactly 1 byte, an integer between 0 and 255. So it's an 8-bit byte. It's a bit like a tuple or a list or a string, but every element has to be between 0 and 255. And like string and like a tuple, it's immutable. Once you create it, you can't change it, but you can then reuse the variable name to point to a new one. The 3 ways you can create them, you can create them using a sequence of integers. And it will represent them as ASCII characters if they're in the ASCII range. If they're not, then they'll represent them as hex characters. AB hex FF. If you do have a literal form of it, you can just use it like a B like that, and that will work. You might also have a string coming from somewhere. So that's a string. If you want to turn it into a byte, then we can encode it. Which, if you're around for previous Pythons 1 and 2, you're very used to. Before the Unicode was invented and then became the default, you're very used to encoding and decoding manually. The brilliant thing about Python 3 got rid of that. Anyway, back to my example. We're going to iterate over it. You can see that each element is returned as an int. Another sneaky way to do this is, rather than iterating through it, you can just let the list function iterate it for you. So that will give you a nice list of integers. So as I said, they're immutable. You can say, give me the first character, but you can't overwrite it. So you can reassign this name to a different byte string, but you can't change it. So if we want to change the H to a B, we have to have the B, and then we take a slice. We take the rest of the bytes, and we combine them. If you've seen the other Void video on pointers, you'll know that when we make a new immutable object, we're just pointing this reference to the new version. It's actually a different bytes object because, as we can see, it's pointing to a different location in memory. So you can do quite a lot with text. The web is text, machine learning is text, all that natural language processing in my background, that's text. But eventually you're going to want to use some kind of binary data as well, like network packets, images, videos. For those kind of things, you need to be able to use bytes. Also, C, in the actual implementation of Python as well, you're going to have to use bytes. All right, thanks for listening.